Well, in the last class we have seen that black body radiation and we have seen that graphs, intensity versus wavelength. Now we will see the Planck's quantum theory. Who is that? Max Planck has given theory that is called Max Planck's quantum theory. So what it explains? So mainly it explains the black body radiation. Mainly it explains to explain the black body radiation, Planck gave quantum theory. To explain the black body radiation, so the energy is emitted or absorbed. So how it is happening? So to explain that one, Max Planck given theory. That theory is called Max Planck quantum theory. Next, what are the important points? So, emission of radiation is due to charged particle. So, in the last black body radiation also told that radiation because of the charged particle, that is electron. And next, radiation is associated with energy. So, particular radiation which contains particular energy or frequency or wavelength. Any charged particle that causes the radiation. Next, that radiation having the associated with the energy. Next, the radiation energy, the radiant energy absorbed or emitted by the in the form of small packets. The energy is absorbed or emitted. That energy is absorbed or emitted, that is in the form of small packets. That small packets of energy is called quanta. What is that? The energy emitted or absorbed by a body, that energy is in the form of quanta. That is a small energy packets you can say. What we can say? Energy packets that we call quanta. So energy is directly proportional to the frequency. Energy is directly proportional to the frequency, that is E is equal to h nu. E is equal to h nu. So h is a Planck's constant. H value 6.625 10 to the power of minus 34 joule second, or 6.625 into 10 to the power of minus 27 in second. Joule second is a SI unit. H is equal to 3.99 into 10 to the power of minus 13, or nearly 4 into 10 to the power of minus 13 kilojoule second per mole. So energy is directly proportional to the frequency. E is equal to h nu, that is Planck's constant, which is 6.625 10 to the power of minus 34 joule second. 6.625 10 to the power of minus 27 egg second. 3.99 into 10 to the power of minus 13 kilojoule second per mole. So next, energy is emitted or absorbed by a body, that is equal to nhν. What is the n is here? Simple, that is value 1, 2, 3, 4. So what is the 1, 2, 3, 4? So the energy absorbed or emitted by a body is integral multiple of h nu. So energy is absorbed by a body or emitted by a body, that is integral multiple of h nu, that is E is equal to nhν. Is it clear? Suppose some amount of energy is absorbed, either one energy packet, so 1 h nu, two energy packets, 2 h nu. So energy is equal to the integral multiple of h nu, either absorbed or emitted. Either absorbed or emitted, that is integral multiple. The energy is integral multiple of h nu, and there is a E is equal to h nu. That's why you can say energy is quantized. What is the meaning of quantized? That measurement we can calculate. Is it clear? So for example, I am walking on the floor just normally. How many steps are there, can we say? On the floor we cannot say. Suppose I am climbing that one floor to another floor. So we are having the steps. One step, two steps. So which we can count? Which we can count easily, that we call quantized. Here energy is also quantized. So energy of any body, whether emitted or absorbed, is equal to the integral multiple of h nu. That is E is equal to h nu. That's why that energy you can say quantized. E is equal to h nu. So radiant energy is propagated in the form of waves. Either absorbed or emitted radiation moves in the form of waves. That is a Planck's quantum theory, or simply you can say Planck's quantum theory. So Planck tried to explain the black body radiation. Try to explain the black body radiation by using the quantum theory of radiation. So what are the important points? Emission of radiation or absorption of the radiation because of the charged particle. The radiation associated with some energy. So what is the energy we are calculating there? Suppose the radiant energy either emitted or absorbed in the form of small packets. That is in the form of small packets that we call energy packets. That we call energy packets. We call quanta. What we call that? Quanta. That is E is directly proportional to h nu. So energy increases, frequency increases. That is direct relationship. E is equal to h nu. H is a Planck's constant. This is a value we have. Next, energy is equal to integral, either emitted energy or absorbed energy. That is integral multiple of h nu. That is energy is quantized. E is equal to h nu, 2h nu, dh nu, n is the value. Radiant energy propagated in the form of waves. Energy is propagated in the form of waves. This is the Planck's quantum theory. Okay, now we'll see the another one, photoelectric effect. What is that? Photoelectric effect. So, what is the photoelectric effect? The phenomenon of ejection of electrons. The phenomenon of ejection or removal of electrons from surface of a metal. From surface of a metal when a light of suitable frequency. When a light of suitable frequency strikes on it. What is that? The phenomenon of ejection of electrons from the surface of the metal. Surface of the metal, we are removing the electron when a light of suitable frequency. What we are saying that when a light of suitable frequency we are applied on the surface of the metal, the ejection or the removal of electrons. Suppose if you take this is a metal, we are sending the beam of light. So on the surface what we are having? Electrons we have. So if that suitable frequency we are sending, we can eject the electron. So that phenomena is called as photoelectric effect. What we call that? Photoelectric effect. The phenomenon of ejection of electrons from the metal surface of metal when a light of suitable frequency strikes on it. When a light of suitable frequency strikes on it, that is called photoelectric effect. The phenomenon of ejection of electrons from surface of metal when a light of suitable frequency strikes on it. So suitable frequency is required to remove the electrons from the metal surface. Okay, here metal is there. This is the incident beam. We are applying on the, or we are focusing on the metal surface here. Electron is released. The electron we are called photoelectrons. What we call that? Photoelectrons. So low ionization potential elements like potassium, rhodium, cesium. So they are having the lowest ionization potential. So minimum frequency is required to eject the electrons. But here one thing you have to remember: different elements are having the different frequencies. Is it clear? So some elements easily can donate the electron, some elements somewhat less easily donate the electrons or eject the electrons. That is depends upon the nature of the metal. So for each metal a certain minimum frequency is needed. For each metal a certain minimum frequency is required to eject the electrons. That minimum frequency is called as threshold frequency. What is that? Threshold. Threshold. Threshold frequency is required. Minimum frequency to eject the electron. Is it clear? For example, here I am having this chalk holder. So if I want to remove this chalk holder, I want some amount of energy. Suppose 100 kilocalories are required, for example. Suppose if I give the less than 100, can I take this one? No. Yes or no? If I give the less than 100 kilocalories, I cannot take this chalk holder. If I give that more than 100 kilocalories, then only I can take this chalk holder. Is it clear? I can displace this one. Like that, to eject the electron from the metal surface, minimum energy is required. That minimum energy is called threshold frequency. So Einstein explained that photoelectric effect, a beam of light behaves as, so what is saying that a beam of light behaves as if it were composed of stream of particles. So what is saying that the beam of particles are composed of stream of particles. They are called photons. So in that Max Planck, he has given theory, quantum theory of radiation. He said that energy in the form of small packets that we call quanta. So here he is saying that the stream of particles, the beam which is composed of stream of particles, that is called as photons. That is, photons have definite amount of energy. How we are discussed in the quantum theory of radiation. There also E is equal to h nu. Here also E is equal to h nu. So the energy of radiation is absorbed or emitted. That is integral multiple of h nu. So like E is equal to h nu. So now E is equal to E naught. Look at here carefully. E is equal to E naught or W work. This is the work function. So E is equal to E naught or W plus K. So the amount of energy what we are giving, the amount of energy what we are giving here, it is used to convert the removal of electron to do the work plus the extra amount of energy what we are giving, the extra amount of energy what we are giving, that turns to increase the kinetic energy of photoelectron. Is it clear? So that is E is equal to E naught or W plus K. That is E is equal to h nu, E naught, h nu naught plus K. So kinetic energy is equal to h nu minus h nu naught. Listen carefully. Here I am taking the chalk holder now. So some amount of energy is required to take the chalk holder. So that is the threshold frequency. 100 kilocalories I am giving. Suppose if I give them more than 100 kilocalories, what will happen? The work function is constant. One electron is constant. Then what is happening there? The kinetic energy of that electron will increase. Is it clear? Is it clear? The kinetic energy of the electron will increase by increasing the frequency of radiation. Frequency of radiation. Is it clear? So now Ke is equal to h nu minus h nu naught. So nu is greater than nu naught, for example. So what is the nu here? Incident frequency. When incident frequency is greater than threshold frequency. Just now I told you. This is the incident frequency what I am giving to this. So some threshold frequency it must have. So to remove this particular, isn't it? So that incident radiation is more than or double. Incident radiation is double.